Hey guys, it's PCTFREE. In this video I'm going to show you the effects of so-called block space utilization parameters on performance. As we've discussed in previous videos, Oracle is nice because it lets you tune and set quite a number of things about the database. You can influence a number of low-level behaviors on a variety of levels, and one of which is a setting called %free. There's a complementary setting called %used, but we won't talk about it so much in this video. But %free is basically the amount of free space Oracle will leave in a block in order to allow room to do, let's say, updates to existing rows that may consume or may cause the rows to consume more space than they did initially. Let's say you create a record for a customer, but you leave a certain field like their address blank because maybe you don't know it when it's first created and it's something you come along and fill in later, or maybe you fill in a phone number later or something along those lines. Those things would cause the size of your row to increase. If you leave some space in the block via this %free setting, again it reflects the amount of the percentage of block space that you can leave free for updates to the rows that are in the block, then Oracle has a little bit of room to fiddle with things. So a high setting of %free means that we have lots of room to update blocks, but the same amount of information is going to be spread across many more blocks than it would otherwise. So in this demonstration, we're going to show you how a high %free setting has some performance impact on a set of blocks. Basically what I'm going to do in the demo is I'm going to create a couple of tables. One is going to have a %free of 0, and the other is going to have a %free of 50. I'm going to load each of these with data and then see how they perform. So I'll jump into, I'll grab my code here for the first one. This particular query is going to create a table called allObjects0. You can see I'm putting in my users table space and giving it a %free of 0. And what I'm doing here, select star from all objects where 1 equals 2. Nothing is going to satisfy the logical condition 1 equals 2, so no data will be pulled. This is kind of a quick and dirty way for me to match the structure of the all objects table. Or all objects is actually a view, but if I did a describe of all objects, you can see there's a fair number of columns in there. If I do a select count from all objects, you're going to see that there's a fair amount of data in here. This has a row for every object in your database to include objects that Oracle maintains for its own purposes. So there's going to be a fair number of records in all objects. Here I'm just using all objects as kind of a quick way to get some data that I don't have to make up myself. So I'm going to take this query, I'm going to run it from the SQL command line. Cool. I've created my table. If I describe all object 0, you'll see that it has the same structure as all objects. Right now it has no rows in it because again we're 1 equals 2. What I'm going to do is I'm going to insert into all objects 0, select star from all objects. It's going to give me my 12,000 or so rows. Okay, 12,097 created. And then I'm going to run this like 4 times. I'm basically going to insert all the contents of all object 0 into itself. As you can imagine, that's going to make the number of rows being added progressively greater and greater. Basically, I just want a large enough data set so that when I run queries against it, I can see performance differences. Okay. Slash is going to run that guy again. You can see the number of rows has basically doubled. Run it again. One more time. Actually, let's run it a few more times just so we can start to see some performance lag. There we go. It's starting to be fairly intense, heavy operations. And again, the point of this is just to create enough rows in the table so that I can actually see the difference in performance when I run queries against this table and another similar one I'm going to create. So I'll do it one more time. And this table will have quite a number of rows in it. It's taking its sweet time. Okay, there we go. If I now do a select count star from all object 0, see that I have a good number of records in there. In excess of 3 million are currently in the table right now. what I'm going to do is create another similar table, except this one is going to have a percent free of 50. I'm going to follow the same pattern I did before. Created a table with the same structure as all objects 0. I'm going to stick some initial rows into it, the count of all objects, or I should say the number of rows from all objects. There we go. And then I'm going to stick more rows in there, and I'm going to get it up to a similar number. I'm not going to get it up to the exact number, because actually creating the object itself, the table itself, has changed the number of rows that are in all objects, but the number will be fairly close. For performance purposes, the small number of rows that will be different between the two tables is not something we'd really consider too significant for performance purposes here. I'm going to run this up until I get to that about 1.5 million rows created per one operation. Okay, I'm going to run a quick commit here because I don't think I left auto commit on. I'm going to do select count star from all object, I call it 50, I guess. Okay, and you end up with a similar number of rows, a little more than 3 million. And again, there's some variance there, but that shouldn't make too much of a difference when we're comparing performance across the two tables. Okay, so I've set up my tables. What I want to do is set timing on in SQL Plus, because I want to measure how quickly certain operations are going to happen. Set timing is on, and I'm going to bounce the instance so that any data that's cached in memory is not going to have any impact. And I'll hyperspeed through that stuff, or kind of skip through it for the purposes of the video here. Okay, my database is up and available, so I'm going to run this. Select count from all object 0, where object name has an uppercase E in it somewhere. I have timings on already, so when I run this, I should get a total amount of time. What happened there is I have so-called smart quotes in there from taking it out of PowerPoint. Fix the smart quotes by putting in regular apostrophes. We should be good to go. I am logged in as the wrong user, probably. That's right, I'm connected to sysdba. Do this. Because I was connected to sysdba, it thinks I'm running under the sys schema, I believe. So let me try this. There we go. I initially created my table as under the system user. All right, so it took roughly 3 seconds for me to return a count there. What I'm going to do is bounce the instance so I don't get any caching effects or anything like that in memory. I shouldn't have any caching effects between these two tables, but just in case, we're going to kind of shut it down and start it up clean. Oracle has started up, and now what I'm going to do is select star from all object 50, where object name like E. Now, what we would expect here is because with 50% free in all object 50, the data, those 3 million and some odd rows that we've put into this table, should be spread out over a significantly higher number of blocks than would have been the case for all object 0. And because the data is spread out over a significantly higher number of blocks, the database has to do more work, it has to do more intensive disk I/O, and again, disk I/O, at least with traditional magnetic hard disks, which is what my laptop here has, is going to be about the most resource intensive thing you can do in a database. We would expect that that higher number of block reads that comes from having a lower data density would make this operation on the all object 50 table considerably slower than the similar operation that we just performed on all object 0. So the all object 0 query took about 2.92 seconds or something like that. We would expect this one to take something meaningfully in excess of that. Let's see if it actually works. Let's say query, object 50. It runs. It's thinking. And this one took approximately 7 seconds. Now, I don't know that that ratio would hold every time we would run this this experiment, but you can see it's retrieved a similar number of rows to, 2,187,520 versus 2,188,000, so fairly similar there. And the elapsed time there was 7 seconds. So again, this is demonstrating the effects of percent free on performance of certain kinds of operations. One thing we would infer from this particular experiment is that if we're doing data warehousing type work, and that sort of work generally the data is bulk loaded into a database, it is not likely to be uploaded or edited once it's there in its final form. So the tables that store data warehousing data we would probably want to set with a very low percent free, because the nature of data warehousing work is to do large reads across many, many rows, in some case millions or billions of rows. And if we want the performance there to be optimal, we would presumably want to set a low percent free. If we were doing an OLTP application, OLTP is online transaction processing, characterized by, let's say, a number of kind of small reads and writes to the database, but essentially you're doing a lot of writing to the database, and you may be updating records, then we probably want to set the percent free something higher than 0, because we want to leave a little bit of room for data in those blocks to change. All right, guys, thanks very much.